These programs are distributed under a Creative Commons Attribution, Non-Commercial, No Derivatives license. You may copy and distribute these programs free of charge. You may not sell them, and you may not alter them. These programs are part of a study examining the value of podcasting as a medium for medical education. If this is the first time you are viewing a program in this optics series, send an email to jyoungmd@gmail.com with your name, position, institution, and city, state, or province and country. Thanks, and enjoy the podcasts. This is definitely a don't try this at home lecture. This is fitting hard contact lenses as described in the textbooks, but not a method I would particularly recommend for actual real life patients, or at least one to be used in supplement with other fitting practices. But let's deal with the optics portion of this. You can view a hard contact lens as a device used for holding up the tear film. The hard contact lens also has some power of its own, and that's what we're going to be calculating today. And the hard contact lens also introduces a tear lens. It introduces a gap between its back surface and the front surface of the cornea, and that gap is filled with tears. And that gap is not uniform in thickness, so that gap has some refracting power too, and we refer to that refracting power that's introduced by this layer of tears caught between the contact lens and the cornea as a tear lens. So in terms of steps of what we're going to do, the first thing that we're going to do is we're going to introduce a little bit of vault to the back surface of the contact lens. We want it to vault over the flattest K. The amount of vault is variable and is something that the clinician chooses. I want to show you how vault fits in, so I'm going to pretty much arbitrarily choose a vault of 0.5 diopters, meaning that I measure the flattest K. Let's say that the flattest K is 43. I'm going to choose a back curve to the contact lens that is going to have a curvature equivalent to 43.5. Now, in truth, we designate the curvature of the back of a contact lens in terms of its radius of curvature, but that's something that's easily convertible with a keratometer, with a keratometer that anyway directly measures the radius of curvature of the anterior surface of the cornea. Okay, so base curve is equal, but we're going to use diopters for this example because it's easier than converting back and forth. The base curve is going to be the flat K plus 0.5, and that's going to introduce a tear lens. And that tear lens is going to have a power. Let's figure it out here. If the cornea were spherical, what is the power that the tear lens would have if we're vaulting the K by 0.5? Well, this is a tear lens that is thicker in the center and is thinner towards the edge, so it's going to be a plus lens. And what's the power of the plus lens? It's 0.5. So even by putting a plano hard contact lens on a spherical cornea such that the back curve of the contact lens vaults over the cornea by 0.5 diopters, we're creating a situation in which we've put 0.5 plus 0.5 onto this eye. And in order for that contact lens to be neutral, to be zero power, you would have to make the contact lens minus 0.5 just to compensate for this plus 0.5 tear lens that we've introduced. Okay, so anyway, step 1, base curve is equal to flat K plus 0.5. Step 2, which is easy for most people who work in minus cylinder anyway, is we're going to convert the manifest refraction to minus cylinder. And we've gone over this ad absurdum. So we're not going to go over how to convert from minus to plus cylinder or from plus to minus cylinder now. Suffice it to say, do it. And the next thing that we're going to do is to disregard the cylinder. So minus 0.5 minus 1.0 axis 180 becomes just minus 0.5 sphere. And the reason is that the tear lens is going to compensate for the cylinder. It's going to fill in the cylinder. the next thing that we do is we need to correct for the vertex distance if the sphere has an absolute value that's greater than or equal to 4. So for a -5 diopter at the spectacle plane is going to be -4.75 at the corneal plane. So we've already seen this and we've done this, but we'll do it once more. The vergence coming off of the back surface of the patient's spectacles in a -5 myope. And again, I'm defining a -5 myope as someone who wears -5 spectacles. The vergence coming off of the back of his lens is -5, but by the time that it hits his cornea, it is a vergence of only -4.72. So the -5, and we'll round the 4.72 to 4.75. The -5 spectacle is going to be equivalent to a -4.75 contact lens at the corneal plane. That would seem like it's the last step, but it's not. The last thing that we have to do is we need to subtract out that plus 0.5 tear lens. So we need to add -0.5 onto the final power. So although we got a final power of -4.75, we need to add in an additional -0.5 to compensate for our tear lens generated in step number 1. So the final power for this contact lens is going to be -5.25. That is to say, -4.75 minus 0.5 to compensate for that tear lens for a final power of -5.25.